Welcome to SwarmCast, a podcast that's dedicated to exploring the key AI and data science topics with industry leaders. SwarmOne AI, the autonomous AI infrastructure platform for all AI workloads, from training through evaluation and all the way to deployment, self-setting and self-optimizing in all compute environments, whether on-premise or on cloud. So I'd like to introduce today's renowned guest, Mike Erlihson, or Dr. Mike Erlihson, should I say. Mike is a leading AI expert specializing in deep learning and data science with a PhD in mathematics. As head of AI and cybersecurity domain, he brings extensive experience in AI research, having reviewed over 400, and perhaps even more, deep learning papers. A prominent AI influencer, lecturer, and scientific content creator, nobody in Israel does not recognize Mike Erlihson. So, Mike, very happy to have you today. Let's kick off with a quick introduction about your own background and experience. You started in pure mathematics, right?
Yeah. First of all, thank you for inviting me to speak in your cool podcast. I'm really happy about this opportunity. And, I started from pure mathematics. Yeah, my first degree, my BSc degree, was from the Moscow Innovation University from Moscow, and it was not in pure mathematics. It was in computer science and mathematics, and I did there also the second degree, the master degree, and then I emigrated to Israel, and I wanted to continue my learning path because I wanted to do PhD because actually everyone in our family has a PhD, so I got no other choice.
It's kind of a pedigree.
Otherwise, then doing PhD, and then I came to the Technion. I was told that if I wanted to do some computer science, but I was told that I need to do many courses in order to be accepted to the second degree, just to the second degree, not to the PhD.
Okay.
And then I came to the mathematics faculty, and they told me, okay, you can start second degree. I couldn't start the PhD there straightforwardly, but second degree, and I started learning there without any courses with very high average grade, and I started learning there, studying. And I completed my master degree in applied mathematics. It wasn't pure mathematics, it was applied, but it was more pure than applied, actually. Quite esoteric stuff like random combinatorial structures and Libet shapes of some stochastic processes. And my PhD was in applied mathematics, but still it was much closer to pure mathematics than to applied. So actually, you are correct. My journey started from let's call it pure mathematics, 90% pure mathematics.
Got you. So, what was a question that came into my mind before we sat down to speak is what was actually your inspiration from taking yourself from pure mathematics, and what I understand now for the first time is that you've actually done your second degree twice. So what inspired your so diligent journey into pure and applied mathematics into the AI industry and the level of expertise that you entertain today?
Actually, there are several possible answers to the question, and I'm going to give you an answer which I love the most. And the answer is, if you are doing the pure mathematics, I think I have five papers. All of them were written before 2008. And I'd like to ask you, how many people in the whole world, in the whole scientific community, are capable of understanding these 5 papers which I wrote? I want to ask you, what do you think?
Well, I can judge from many other papers. It's either I decided to spend a whole weekend and bang my head into other concepts and leave with 70% understanding, or I don't understand. Okay. You really have to move very, very deep.
I guess that in the best case, there are a few hundreds of mathematicians in the whole world who are capable of understanding papers I wrote. And it doesn't sound good for me. It didn't sound good for me then, and it doesn't sound good for me now. And I wanted to contribute, let's say, to the humanity. I want to do something significant, and I wasn't capable to do it in pure mathematics. By the way, there are some mathematicians who are capable of doing it in the framework of pure mathematics. But I'm not. Maybe I'm not talented enough to do it. So I decided to leave mathematics and go to the industry and try to contribute the humanity, the world, not the pure mathematics, and my contributions to the stuff which are developed by the companies.
And that was essentially AI. When did you make your move?
It wasn't AI because I started my career in high tech almost 20 years ago. It was 2006, and I haven't heard. I'm not sure that I knew then in 2006 that I knew what is AI. I knew it is something which is called artificial intelligence, but I started my journey in high tech not from AI but from different stuff. I started from computer vision, and when I went to the company which were developing some wireless communication systems, chips, and then base station of fourth generation, and then I taught some course in the Beersheba University about it, and then I came to Samsung, and only in 2016, at the end of 2016, some random lecture, and I want to emphasize it because all this journey to the AI was quite random. Why I call it quite random? Because I could get to the AI to the deep learning in 2020 because I was working in Samsung and solid state device, almost no relation to machine learning then and to AI, and then some random lecture which I even didn't want to attend, And I just got to this lecture, and my eyes become twice bigger because I saw all this mathematical structure, all this convolutional neural net and AlexNet and LeNet, and I saw all this stuff actually working, and all this stuff actually working better than all these manually built features. And then I told to myself, okay, Mike, now you need to go to deep learning. And then, deep learning slowly transformed to AI. And this was the beginning of my journey. And I'm very happy about it because before getting to deep learning, I couldn't fully say that I love what I'm doing. Okay, now I not just love what I'm doing, I'm in love what I'm doing now.
That's really beautiful.
Okay, and it is stronger.
That's really beautiful. That's really beautiful. Yeah, I recall in a different scenario, in a different world, and I assume a year or two later, but that moment when you see an AI model really working for the first time looks like magic. It just looks like magic, and everything that comes after it, whether more complicated or simpler, it's always magic. And I think that this is what causes people to really fall in love with AI.
Yeah, exactly. For me, by the way, after DeepSeek, it is very common to call it the aha moment. As for me, the aha moment in deep learning, in the artificial intelligence, was this lecture in the end of 2016.
Right. Yeah. Right. For me, by the way, the aha moment was after running a model to identify between cats and dogs, and there was a small function I included inside to understand which features were the most interesting or the most had the largest weight on the model.
The most salient. Salient.
Yeah. To understand what is a dog and what is a cat, and it turned out that the eyes had the deepest, the most important features, and it really struck me how this becomes so similar to human beings, because human beings also look directly into the eyes, and the fact that this particular model, a small little model with a measly data set, was also looking into the eyes was like mind-boggling for me. But enough for that. So What developments in AI and data science do you find most excited about right now? And you really got to keep with the pace because this changes on a monthly basis.
Okay. I think, first of all, it is really hard to answer the question because as you mentioned, there are a lot of developments and there are a lot of interesting developments, and there are a lot of stuff, all these language models on these agents and then multi-agentic flows and stuff like that. And now what is really popular is the model context protocol of Anthropic and now of OpenAI. And after Anthropic put some blog about it, I think there were 100 companies which did it in the week after it, and now OpenAI joined the celebration. They can define it this way, and it is what is really exciting is the rate of innovation. The rate of innovation is exponential, and the exponential, it is not just exponential of 2 weeks. I think it is exponential in X square. The rate of innovation is really huge. By the way, I don't think that anything which comes out from these big companies, large companies, is really very innovative. I think about 20% of the stuff which are published by on the media is really innovative, but still, if I compare it to the state of the data science and the AI and machine learning, say 5 years ago, this rate of innovation is enormous. You just can't imagine this speed of innovation. Even 3 years ago, the number of tools, the number of new models, the number of systems and packages. You can't just follow after all this innovation. I am in many WhatsApp groups and I'm trying to follow. I'm trying to be really updated. It is really hard. I think in 1 year from now it will be totally impossible to be updated of all what is happening in AI. But what is really exciting for me now is what is called wipe coding, and I explain. Okay. And I think that it is very important concept, but I think that there is some misuse of this wipe coding. Everybody knows what is wipe coding. You don't write your code. You tell to Cursor or to Copilot or to something. There are dozens of tools which can write your code for you. But the concept is that the new code is your English. Is English. For me, as a data scientist, as a quite experienced data scientist with a quite vast and in some places quite deep knowledge on AI, it is cool because I don't need to spend my time on coding. For example, I wanted to do something and it involved scraping of 15 different websites, and 3 years ago it would have taken me about days, maybe weeks. Now, how much time it took me? 2 hours. 2 hours.
Wonderful.
Yeah, and I didn't write any. Maybe I write one string of code, one string of code, some print, some logger. I just, all my bags. There are some bags I asked to write a code, and then Cursor. I'm using Cursor. I love Cursor, and then Cursor write a code, and then there's some bags. I try to run it. It was some bags, and I just did copy paste, and the only word I wrote it fix, and 2 hours after it, I have a working code. But it is not some code which goes to production. It's not some game for me. I wanted to do something for me. It is not so important. All security consideration. It is some code I wanted to do scraping of some paper reviews. As you mentioned, I love paper reviews. I want to do scrapings of 15 guys who are doing paper reviews, and I wanted to summarize their reviews and to learn from them. Mm-hmm. But if you want, but for data scientists who has less experience and who want to put this code into production, this wipe coding concept can be quite dangerous, because I don't care about some security bugs in my code. It is not important. But then you're using this wipe coding to put your code into production. And if you're using wipe coding and you don't understand your code and you don't understand the code in depth, it can be very, very dangerous. So from one side, I'm really excited because it really helps me. It's really shortens my way from thinking about some concept and implemented it, which 2 years ago would have taken me weeks in some cases, and now it takes me hours. But for younger data scientists with less experience, you should use it, how do you tell it in English? The grain of salt, You can use wipe coding, but you must understand your code, okay?
Yes. I have a feeling that it is the difference between the code as if you're a student, the code as you write it, as opposed to having code in a textbook, and then your mission is to understand it. Now, if you jump over the understanding, then you're jumping over a very dangerous part. I perfectly agree with you. And with all this turmoil and advancement in AI, do you feel that the software part of it, the software part of the stack, or I should actually rephrase my question, do you feel that the hardware part of the stack keeps pace with the software part of the stack, or are we in any dissonance in this regard?
I'm not sure that there is any dissonance. I think, do you know, are you familiar with the bitter lesson of Richard Sutton, of this very famous blog, in which he tells that the most advancements in AI were motivated and were built on the compute, actually, and more on the clever engineering ideas of most profound and famous data scientists. So I think we still are relying on this compute, of huge amounts of compute. You can just take a look on these companies like Meta, like Amazon. They have Google. They have an infinite amount of compute, and these are companies which are building the most advanced language model. For example, if I wake up someday and I hear some small company developed some large language model, some foundation language model from scratch, I will be very surprised because you need the tens of thousands of GPUs to do it, and you need all this. Even if you have tens of thousands of GPUs, you need your infrastructure. So most of the advancements in AI are motivated still motivated by huge amounts of compute. And by the way, just yesterday or day before yesterday, I wrote a blog about it. My my thoughts about this bitter lesson of Richard Sutton blog. This blog is dated of 2019, maybe. I think the situation has been changing now. All these clever usage test time compute and the RAGs and you are now using your Anthropic and or OpenAI or Gemini. It is not just LLM.
Right.
It's multi-layered systems, it's RAGs and databases and caches. It is very, very complicated system which can also do searches on the internet. So it is not just compute now, but still, if you don't have compute, you can develop, say, foundational models. But you can develop some small. Everyone knows what is DeepSeek. Everyone knows what they did. And actually what we did is some kind of democratization of LLM training. And I think that now even quite small companies can build some not very large and not from scratch, some very clever LLMs. So the compute is important. The hardware is important. But I think 1 year from now, 2 years from now, maybe 3 years from now, I feel it. Maybe I'm wrong. I feel that the rate of the development of hardware is going to slow down. what we see now, we see that the engineering tricks, engineering ideas, how we build all this infrastructure, all this ecosystem around LLMs changing very fast, and I think that many new developments in AI will come not from just huge amount of compute and very developed infrastructure, but from some clever engineering ideas around all these LLMs. Now LLM is just a building block. You can do very smart things and you can build very smart tools based on LLM. It is not just LLM, but LLM is at the heart of these systems.
Yeah, thank you very much. And we're also going to get to your interaction with SwarmOne later on. So if you can summarize, what challenges do AI professionals in cybersecurity companies especially encounter when they develop and evaluate and deploy large models to production? I mean, in terms of execution, their actual execution.
Okay. I think the issues data science are having in the cybersecurity companies are not very different from the other companies. Maybe in cybersecurity companies they are mostly dealing with the data which is not natural language, but some logs and JSONs and HTML. So, and I'm not sure our LLMs, even the newest one, have been trained on enough amounts of this data. So there is there is a need maybe, and I know a couple of companies which are trying to do it. There is some need in some cybersecurity LLM, some cyber LLM, some foundational cyber LLM. But so it is a common issue. If you go to the health domain, if you go to many different domains, you can take some LLM and you need to find it. Okay, and in cyber the situation is not very different from other domains. And now you are going to fine tune your model, and it is not very simple. Okay. And it is not very simple, even you have your data. By the way, the data, the built in your data set is far from being simple. But this problem exists in any domain. Now you can generate your data, but still the quality of generation is not is not sufficiently high in many cases.
Yeah.
So, but let's put this data issue aside, and now you need to fine tune your model, and still with all your frameworks, with all your tools of fine tuning your models, and we have maybe thousands, okay, at least many hundreds of tools and frameworks to train your models. It is still not very easy. Not very easy in terms of now you have some model and you have some data set, okay, and you just want to fine tune it, okay. Well, what I mean by fine tune it, you are not just training the model. The model training it is the easy part. The monitoring of training and the results evaluation and all this stuff and then where are you running it? Then you are training your model, so you need to go to AWS or Google. But still, it is not plug and play. It could be very cool if I have some model, some checkpoint, some node model, 13B, not very large, and I have my data set, and I have my loss function. I know what is my loss function. It is nice token prediction, or I can define my loss function. I'm data scientist. I understand very well in loss function, and I understand less in all this hardware consideration. I want to go to AWS without all this configuring all these machines and then choosing the GPUs. I want just to train my model. I want plug and play. I want to give the model. I want to give the training configuration, and I would just straightforwardly train my model. Okay, and this thing which sounds quite trivial, currently is hardly possible. You need to go to AWS. Even the SageMaker, it is not so simple. Yeah.
So maybe this connects me to my next question, which was if you could share with the audience how you actually benefited from SwarmOne as the principal data scientist at Salt Security. For example, in terms of flexibility of the platform for AI infrastructure, setting this up, actually making this, what you said, this trivial move, actually bring it to existence. Could you share your experiences in that regard?
Yeah. I can tell you in one sentence that this experience was very positive, and at Salt, models were highly customized. Okay, what do I mean by highly customized? Which is the models which we trained were quite small models. It was 2 or 3 years ago. These models were quite small and they're quite customized, and some LSTMs and GRU and some very light transformers. And these models don't have full support in Hugging Face. And guys who know how to train models with not full support in Hugging Face they know that it is far from being simple. If you work with the bare metal AWS or even SageMaker. And the Swarm platform, it actually was quite easy, and they even helped us a couple of years ago to fix our bugs. But the most important thing that our data scientists didn't have to run around all these AWS configurations and to configure it, and you choose H2, H100 or A100 GPUs in AWS, and all these theorem configuration, which are not really. It is important, but I don't want my data scientist to waste time in stuff like that, because I think it can be done automatically. And the Swarm in Swarm platform, it can be done automatically. I don't, for example, I don't see any error in which word CUDA appears. I'm a bit frightened. This CUDA word scares me out. But still, all this model training was very simple because you just need to define your model, just need to give the code of the model. Now you can define your loss function and when you want your checkpoints and all this train set, validation set, and test set, and it just runs. I don't need to configure machines, and I don't need to install some package here and some package here, and I don't get all these errors about the PyTorch version can't run with some version of some other package which we were getting 2 years ago in AWS. All the process was really simple. You give your model, you give your training configuration, and you're just training your model. And one more important thing, it was much less expensive. It was much cheaper than AWS.
Well, thank you for that. Yes, it was. It was then, and already now it can also run on your own compute. So whether that compute is an AWS or Azure OCI or GCP or Lambda Labs or CoreWeave, whatever, it is a software tool that can reach those that simplicity that you were alluding to in regards to the activity of the data scientist. So, well, thank you very much for that. And that's really important to hear from someone who's actually been using it for years. And so how do you, coming back to cybersecurity, which is part of your essence, essential activity focus in past years, how is cybersecurity field changing and adapting to the growing risks of AI-powered threats, if at all?
It is. The answer it is trying to cope with it, and the risks are really growing. And the reasons, and the main reason that these risks are keeping growing is because now you can easily engineer very sophisticated attacks for example, on your API, on your cloud infrastructure with AI, 3 years ago, it was hardly possible. Each attack, you need to develop it and then to think about it. Now we can engineer very complicated attacks just with some language, some language model. You can give it the data, and it can just engineer very sophisticated and very hard to catch attacks. And it really affects the cybersecurity field, because now you need to incorporate the ability of detecting and catching these attacks, and it is not very simple. And the many old methods, to detect, stuff like SQL injection and stuff like that. You should do it as well, but now you have to add capabilities of detecting and avoiding these zero-day attacks, because you don't know what will come out in 2 days. Maybe, and it's called zero-day attacks, and these attacks are AI generated, and you have no choice but to leverage AI to stop these attacks. But all this, this incorporation of AI capabilities into cybersecurity products is not so simple. Before it, you have some quite not very complicated methods of anomaly detection and some regexes and dictionaries to catch stuff like SQL or SQL injection or injection like that. Now you need keeping all this backward compatibility with the old stuff. You need to incorporate some AI capabilities in your project. And it's not very simple. It's not very simple because our plain models, I think if you take, for example, Claude or OpenAI, ChatGPT 4.5, they know cybersecurity. They understand cybersecurity, but the devil is in the details. Okay, if you ask ChatGPT or Claude or Gemini, if you ask some general question about cybersecurity, it will give you a good answer. But now, when you drill down to the real case, it is not so simple. So you need your dedicated models. You need to train. You need to fine tune models which are specific to a cybersecurity domain. Cybersecurity domain is like math. Math is huge, and cybersecurity is not smaller than math. You have cloud security, and have WAFs, you have API security, you have DLP, the data loss prevention, and many things. Network security, which is also very important. But so maybe I think the future of cybersecurity is quite small, dedicated models for each domain. So we are doing some network security, or if you want to cover all the cybersecurity stack or most of them, you can just put several models. Each of them are they're fine-tuned on a specific cybersecurity subdomain, and you need to have these models working together. And it is not so simple because the stuff is changing. I used to say that the distribution is not stationary. The stuff is changing. New attacks emerge. So these models, you need to retrain them. You need to fine tune them. Maybe you need to build some tools for automatic retraining of the model. So if I can summarize my question, my answer into one sentence, you need to adapt to the new state of cybersecurity domain, and this adaptation goes through incorporation of LLM capabilities into your project, together with the old good tools, regexes, and some basic classic anomaly detection methods.
Wonderful, thank you. I actually feel, in the underlines, in a few of your answers, or in quite several of your answers, the inclination towards fine tuning as opposed to actual training. So fine-tuning a variety of models to address zero-day attacks which are generated by AI and stuff like that. So I would define you as a fine-tuning proponent without even asking you. But
there are quite a few companies which have enough money and resources to train a huge, let's say, 1 trillion model parameters from scratch. There are not too many companies. The price of training such foundational models is going down, but still it is huge.
got you. Well, thank you very much for sharing all of this with us today, Mike. Are there any recommended resources that you can point at for professionals? Any resources you can point at, such as books or podcasts or blogs, or any tools that you'd like to point at, which coincide with your philosophy and your way to approach issues?
It is a very tough question. For serious data scientists, not understanding is not good. So what I recommend is blogs which dive into some math. It's not just you take some LLM, you do some prompt engineering, you do some RAG, without understanding what is going on under the hood. There are a lot of such blogs which dive into math, and there is, I think, 100 more blogs which kind of tell you, okay, you don't understand, you take some LLM, you just connect some RAG, and then you build some agent. It can work, but still, I encourage you to learn. I encourage you to learn how stuff works, okay? And for now, compared to the 25 years ago, when I was doing my second degree and my PhD, this knowledge is fully accessible. You can access this knowledge in YouTube, in Coursera. There are, Medium and Gradient. You have a lot of places you can acquire this knowledge. But I encourage you to learn how things work, not just connect things without understanding.
Thank you very much for this insight. And it actually resonates very well with one of our previous guests, Amit Weiss, the CTO of Numenos. And our mutual perception is that the upper layer frameworks, PyTorch, TensorFlow, Hugging Face, have everything kind of on a silver plate for you. And some of the deeper things which are making deep learning, such as activation functions, as easy as that. And what activation function are you going to use? Now, it's as if there are only 3 activation functions in this world, and all the rest are irrelevant, and definitely some that you can actually think of yourself. So this is just an example for so many things which are happening in the deep layers of a deep neural network that have become run-of-the-mill and are not researched anymore by people researching the field. And it's a very young field. So this phenomenon is rather surprising, and I would say, it's a little downer to see things just connected and, okay, now let's have an answer, instead of let's look inside and see what we can actually improve and do it this way. So you got a resonance with one of our previous participants.
By the way, nobody really understands for now what is going on inside your LLMs. Okay, Anthropic is doing great research efforts, and also Google, to understand what is going on. But still, we are not there. So I encourage you to try to understand, to read this research, to ask questions. There are many WhatsApp groups, and then you can ask it in LinkedIn and Reddit. You have a lot of media. You have tons of media. You don't understand something, ask, okay? But still, don't get your stuff as working. It is working, it is okay. It is not okay.
Yeah.
It's not.
Yeah, and I believe that by this you can actually achieve many more aha moments of the type that we discussed in our initial, in the very first minutes of our conversation today. Every picking up and looking under the kilt shows you another moment, or at least has a potential of that, which if you just connect and make it work, you're losing. Okay, so this was very interesting. Where can our audience follow your work, like on social media or blogs or any recent publications?
Okay, I think you can follow me in three main medias. The first of them is the Substack. I'm writing constantly on Substack, and we'll put the links under the podcast recording. We will put some links, and the one is my Substack, and the second one is in my LinkedIn. I'm pretty active there, and I'm sharing a lot of books, mostly about math, sometimes about physics. And also I have two Telegram channels, one in English and one in Hebrew, which I'm sharing my deep learning paper and reviews. As Harel said, now it is about 440 reviews of deep learning papers. So LinkedIn, Substack, Telegram channels. Please follow me. By the way, I'm sharing only deeply technical stuff, which encourages you thinking. By the way, I'm reading tons of papers, and I admit, and it is serious, 100% serious. I'm having aha moments every day. There is almost no day.
Bless you.
That I don't have aha moments.
I'm really thank you, Mike. This meeting was very insightful, as every meeting with you has been in the past.
Thank you.
And I look forward to touching base with you in a year from now and looking back and how nascent was the technology just 12 months ago when we were having this conversation. To our audience, I will say, if you enjoyed this session, stay connected with SwarmOne for more expert discussions and seeing Mike once again. Look up any news from us on Swarm.ai, and I wish you a very good day and a very good week for all of you. Thank you very much. Take care.
Thank you very much.
Bye-bye.
See you.